Swayam Prabha. Digital India. Educated India.
Hello all, welcome back. In the previous lectures we have seen the concepts related to S hydrograph and the methods by which unit hydrographs having different durations can be derived from the given unit hydrograph. So today let us solve some of the numerical examples related to those concepts. So while deriving the unit hydrograph having different durations, that is NDR duration, we have seen two concepts can be utilized, method of superposition and method of S hydrograph. If the duration which we are going to derive is the integral multiple of the duration of the known hydrograph, we can make use of the principle of superposition. But sometimes we may have to derive a unit hydrograph having duration which is not an integral multiple of the given duration, that is n can be a fraction. In that case we can make use of S hydrograph theory. S hydrograph can be utilized in the case of integral multiple also, but in the case of fraction we can make use of S hydrograph only, we cannot make use of principle of superposition. Today let us solve some of the examples related to it. First example is unit hydrograph of different durations using method of superposition. Derive a 3-hour unit hydrograph from 1-hour unit hydrograph. Time hours and 1-hour unit hydrograph ordinates are given to us. That is, we are having the 1-hour unit hydrograph. The known unit hydrograph is having a duration of 1 hour. We need to derive the 3-hour unit hydrograph. Since the known duration is 1 hour and we have to derive the 3-hour unit hydrograph, we can understand that it is an integral multiple of the given duration. So we can make use of the principle of superposition here to derive the 3-hour unit hydrograph from 1-hour unit hydrograph. You know the steps related to it. Here in this case n is an integer, and if n is an integer we will be making use of the principle of superposition, and 3 unit hydrographs will be lagged by 1 hour. So we need to lag it by 3 unit hydrographs are required. So these 3 unit hydrographs superimposed together will be producing a 3-hour direct run of hydrograph due to 3 centimeters of rainfall. Summing up the ordinates of the 3 unit hydrographs will give the 3-hour direct run of hydrograph from 3 centimeters of effective rainfall. Now by making use of the principle of proportionality, we can divide the resulting 3-hour direct run of hydrograph by the effective rainfall of 3 centimeter. That will be giving us 3-hour unit hydrograph. So first what we will be doing, we will be lagging the 1-hour unit hydrograph by 1 hour, then summing up the corresponding ordinates to form the direct run of hydrograph of 3 hours, which is produced due to 3 centimeters of rainfall. After that we will be dividing each and every ordinate of the direct run of hydrograph by 3 centimeters, which will be producing the unit hydrograph of 3 hours. So these are the data given to us. What we have to do, these are the ordinates representing 1 hour unit hydrograph. It is in meter cube per second. So now what we will do, we will lag these ordinates of 1 hour unit hydrograph by 1 hour. How it can be done? So, we will be lagging it by 1 row. So, it is starting from first hour. Then we need to have the 3-hour unit hydrograph. So, we need to lag it again by 1 hour. So, this is the ordinates of 1 hour unit hydrograph lagged by 2 hours. So, we are starting at 2 hours. After this, what we will do, we will sum up the ordinates from column 2, column 3 and column 4. That will be resulting a direct run of hydrograph of 3 hours, which is produced due to 3 centimeters of effective rainfall. This is the direct run of hydrograph due to 3 centimeters of rainfall. Now, what we will be doing, we will be dividing the ordinates of the direct run of hydrograph by 3 centimeters. So, it will be giving us 3-hour unit hydrograph. So, these are the ordinates of 3-hour unit hydrograph which is produced from 1-hour unit hydrograph. So, here we are having the plot showing 1-hour unit hydrograph and 3-hour unit hydrographs. So, you can observe the graphs. 1-hour unit hydrograph is having high peak and the peak is attained very fast. And while looking at the 3-hour unit hydrograph, it is produced a peak after certain time than that of the 1-hour unit hydrograph. Now, let us move on to the second example on S hydrograph. While explaining the S hydrograph concepts, we have discussed about the theory only. Now, let us solve one example related to S hydrograph, then it will be more clear. Derive the S hydrograph from a 4-hour unit hydrograph given in the table below. Estimate the value of the equilibrium discharge from the S curve. Here what we have to derive? We have to derive a S hydrograph from a 4-hour unit hydrograph. While discussing about S hydrograph, we have seen after certain time S hydrograph will be attaining an equilibrium discharge. So, what is the equilibrium discharge? That also we need to determine in this example. So, these are the ordinates of 4-hour unit hydrograph. Now, let us move on to solve the example. The data given are 4-hour unit hydrograph ordinates. First, what we will do, we need to revisit into the concept related to S hydrograph. S hydrograph is obtained by summing dr unit hydrograph with a lag of drs. We are having the dr unit hydrograph, we will be lagging the unit hydrograph by drs. So, that way so many number of unit hydrographs will be lagged and after that we will be summing up the ordinates to get the S hydrograph. So, here we are having the 4-hour unit hydrograph. So, definitely we will be lagging that by 4 hours for producing S hydrograph. And the ordinate of unit hydrograph is given by St minus St minus D. That is, the ordinates of unit hydrographs are summed up together to form the S hydrograph. We can get the ordinate of unit hydrograph by subtracting the ordinate of T minus D S hydrograph from St. This St minus D is nothing but the S curve addition. So, St is equal to Ut plus St minus D. Unit hydrograph ordinate at time t plus S hydrograph ordinate at t minus d. That will be giving us the ordinate of the S hydrograph at time t. St minus d is the S curve addition. Now, we can proceed to solve the example. The ordinates which are given in column 2 can be represented by the notation Ut. And next step what we are going to do, we are going to find out the S curve addition. We need to find out the ordinates corresponding to S curve addition. Then only we can find out the S curve ordinates for time t. We can represent this S curve addition by the notation S t minus d. How can we get the ordinates corresponding to S t minus d? You might have observed while discussing about S hydrograph and unit hydrograph, the ordinates corresponding to time 0, t is equal to 0, in both the cases that is in the case of unit hydrograph and S hydrograph, is equal to 0. First entry in column 3 is the first entry in column 2, that is nothing but it is 0. Now we will move on to get the S curve ordinate, that is ST. It is represented by ST. How can we get ST? ST is given by UT plus ST minus D. So, we are having UT here, you are having ST minus D here, that sum will be giving us the S curve ordinate. So, the column 4 is obtained by summing up column 2 and column 3. What is our column 2? Column 2 is unit hydrograph ordinate and column 3 is the S curve addition. So, if we are adding that, we will get the ordinate corresponding to ST. So, here in the case of time t is equal to 0, we are having ordinates of unit hydrograph and the S hydrograph as 0. And now coming to the second entry in column 3, that is the first entry in column 4. Second entry in column 3 is the same as that of the first entry in column 4. Here we are having 0 and same thing is written over here in column 3. Now we will be summing up the ordinates of unit hydrograph and S curve addition. It will be giving us the S curve ordinate. This way we will be proceeding. This 30 will be written in column 3 and 30 plus 110 will be giving us 140. That is the S curve ordinate corresponding to time t is equal to 8 hours. Now that 140 will be put in S curve addition column, that will be added to the unit hydrograph ordinate 168 to get the S curve ordinate. So, it will be giving us 308. This procedure will be followed in order to produce the S curve ordinates for different time intervals. So, this way if we are proceeding, we can get the ordinates corresponding to the S curve for the entire time durations. So, you can see what we have done. We have written our unit hydrograph ordinates, then we have found out the S curve additions and that S curve addition is added to the unit hydrograph ordinates. Here one thing you need to be careful is that we are adding the S hydrograph ordinate corresponding to a lag of D duration to the unit hydrograph ordinate of UT. UT plus S T minus D we are doing. That is why we are separately making a column for S curve addition. Then we are adding in order to avoid calculation mistakes. So, the same example can be solved by another way. You do not have to always write this column related to S curve addition. You can directly get the ordinates of the S hydrograph. Let us look into that. The same example only, there is no change in the data points. Same 4 hour unit hydrograph is there, that is written over here in column 2 and we are going to calculate the S hydrograph ordinate. So, first entry in column 3 is the first entry in column 2 itself, because S hydrograph ordinate and the unit hydrograph ordinate at time t is equal to 0 is same as 0. So, that will be written over and that is giving us the S curve ordinate. After that what we are doing? We are summing up that what we were doing in the previous case, we were writing it again as S curve addition, which has to be added to the unit hydrograph ordinate at time t. Instead of making separate column, we are directly adding and putting in the column 3. So, second entry in column 3 is the first entry in column 3 plus second entry in column 2. Here what we are going to do? We are going to add 0 and 30. It will be giving the S curve ordinate corresponding to time t is equal to 4 hours. Same step will be repeated. 30 plus 110 will be giving 140. 140 plus 168 will be giving us 308. This procedure we are continuing till the end of the unit hydrograph and we will get the ordinates corresponding to S curve. All the ordinates can be obtained. So, here instead of separately writing a S-curve addition column, we have directly summed up the ordinates to get the ordinates of the S-curve. Only thing is that you have to be careful about the interval by which the data is given. If your unit hydrograph is of 4 hours and the interval given is 2 hours, while adding you have to add corresponding to 4 hours, that is first entry will be put in the cell corresponding to 4 hours. It cannot be directly put just after the first cell. So, that care should be done, otherwise entire answer will be wrong. That is why we are separately making the S-curve addition column. Otherwise, this way you can easily find out the ordinates of the S hydrograph. So, this is the way we are proceeding and we are finding out the ordinates. So, the first part of the question is over. Derive the S hydrograph, that we have done. Now, the second part of the question was, what is the equilibrium discharge or equilibrium runoff value? Look at the curve, you can understand that at t is equal to 40 hours, the ordinate of S hydrograph is 949 meter cube per second. This is in meter cube per second, the unit is in meter cube per second. And corresponding to 44th hour also, it is 949. And 48th hour, again the same value. So, you can understand that as time is increasing, there is no change taking place in the ordinate of the S hydrograph. That is representing the equilibrium discharge. Here in this example, the value of equilibrium runoff is 949 meter cube per second. So, you look at the figure, as the time base of the unit hydrograph is reached, that is around 44 hours, right? The S hydrograph has attained the equilibrium discharge. After certain time, how we are producing the S hydrograph? We are putting the unit hydrographs at a required lag, or we are placing the unit hydrographs with the duration of the unit hydrograph and summing up the ordinates. And we have seen that we can find out the equilibrium discharge. The S hydrograph will be attaining the equilibrium discharge after certain time, that is corresponding to the time base of the unit hydrograph. That is clearly visible from this figure. S hydrograph is given by this blue curve and the given unit hydrograph, that is the 4-hour unit hydrograph, is represented by this red curve. So, now it is very clear how to solve a question related to S hydrograph. That is, if a unit hydrograph is given to you, you can develop the S hydrograph by making use of these principles. Any of the ways you can follow. You can make the column related to S-curve addition separately, or even if it is not there, you can directly add and find out the ordinates of the S hydrograph. Now, we will move on to the third example, that is related to unit hydrograph of different durations using S hydrograph method. So, definitely unit hydrograph of different duration can either be obtained by this what you call S hydrograph method or superposition technique. So, here the question is, derive the 3-hour unit hydrograph from a 2-hour unit hydrograph given in the table below. We have been given 2-hour unit hydrograph. Ordinates of 3-hour unit hydrographs and the corresponding time is given to you. You look at the table carefully. This is the ordinates corresponding to 2-hour unit hydrograph, but the ordinates are given at an interval of 1 hour. So, in this case, if you are not separately making the column related to S-curve addition, you need to be very careful while making the additions. Before moving on to solving the example, let us have a revisit into the steps involved with that. First, what we will be doing from the unit hydrograph, we will be finding out S hydrograph, that is denoted by SA. So, this is our effective rainfall intensity having 1/d centimeters per hour, that is producing the S hydrograph SA, and SA is representing the direct runoff hydrograph subjected to an effective rainfall of intensity 1 by d centimeters per hour, which is starting at time t is equal to 0 and continuing indefinitely. Second step is to lag the S hydrograph by t hours. That is, the catchment is going to experience the same amount of rainfall after t hour duration. So, same effective rainfall pulse, same effective rainfall intensity of 1 by d centimeters per hour is marked over here, which will be producing the S hydrograph with a delay of t hours. That is marked by this red curve represented by SB. For that, what we are going to do? We are going to lag the developed S hydrograph by t hours. And this SB is representing the direct runoff hydrograph subjected to an effective rainfall intensity of same amount, that is 1 by d centimeters per hour, starting at time t is equal to capital T and continuing indefinitely. These concepts you already know, but just before solving the example, I am just refreshing the steps behind it. Now what we will be doing, we will be finding out the difference between them. SA minus SB will be finding out, that is representing the direct runoff hydrograph, which is resulting from an effective rainfall having intensity 1 by d centimeters per hour, but you have to be careful, the duration corresponding to this is t hours. That is, we have found out the difference between SA and SB. So, that is representing an effective rainfall which is occurring for a duration of t hours, capital T hours. The rainfall depth corresponding to that will be T by d centimeters. So, SA minus SB is the response of the catchment for a rainfall of 1 by d centimeters per hour for t hours. This is the effective rainfall pulse input. The depth of that will be T by d centimeters. Now, for getting the unit hydrograph corresponding to T by d centimeters of effective rainfall, what we will be doing? We will be dividing this SA minus SB by T by d. So, TR unit hydrograph is obtained by using this formula SA minus SB divided by T by d. Again, the ordinates will be in meter cube per second. These are the steps to be followed while deriving the unit hydrograph having different duration than that of the given duration. Now, we can start solving the example. We have been given 2R unit hydrograph. 2R unit hydrograph ordinates in meter cube per second is given, but the ordinates are given at an interval of 1 hour. Here I am not going to directly add this, I am putting the S curve addition column. After that, we will be having the S hydrograph. So, first ordinate is same as 0, and after that we will be putting that SA in the S curve addition column, but it should be put in such a way that were that ordinate to be put, it should be put corresponding to 2 hours. So, for 1 hour the same value will be repeated, that is we will write 15 itself. Now, corresponding to 2 hours we will be having S curve addition, that is nothing but 0. So, here the utmost care should be taken, you need to put this S curve addition corresponding to the duration of unit hydrograph. You should not put it at 1 hour. So, that 0 we will be putting corresponding to 2 hours, then we will be adding the corresponding unit hydrograph ordinate. 15 we will be putting corresponding to 3 hours. That way the ordinate should be placed. Otherwise, initial ordinate if you are putting it corresponding to 1 hour, entire process will be leading to a wrong answer. So, this care should be taken care, even whether you are making the column related to S curve addition or not, it does not matter, how you are doing the addition matters. So, if you are directly adding the ordinate corresponding to SA at time t is equal to 0 with 2 hours, then there will not be any mistake. If you are not sure about that, you need to make the S curve addition column and put it corresponding to that time. So, 15 you will be putting over here. Next step onwards there will not be any confusion, and you can get the next ordinate corresponding to S hydrograph by adding 25 plus 0, and next one will be 40 plus 15, that is 55. In that way we will be proceeding and we will get the ordinates corresponding to S hydrograph. Next step is to lag the S hydrograph by the required duration. That is what repeated over here as SB. We wanted to get the 3-hour unit hydrograph, that is here in this case capital T is equal to 3 hours. Given unit hydrograph is having a duration of 2 hours, we are going to derive the 3-hour unit hydrograph. So, capital T is equal to 3 hours. So, we are lagging the derived S hydrograph by 3 hours. That is why we have put the first ordinate at T is equal to 3 hours. Now, next step is to find out the difference between SA and SB. The difference between SA and SB can be found out in this particular column. After that, what is this difference? This difference is giving us the direct runoff hydrograph corresponding to a effective rainfall for a duration of T hours. So, the rainfall depth is not 1 centimeter, it is the direct runoff hydrograph corresponding to a rainfall depth of T by D centimeters. So, TR unit hydrograph can be obtained by taking the ratio SA minus SB divided by the depth of the effective rainfall, that is T by D. Here in this case T by D is 1.5, T is 3 hours and D is 2 hours. D is the duration of the given hydrograph, T is the duration of the required hydrograph. So, T by D is 3 by 2, that is 1.5. Now, what we are going to do? We are going to divide the ordinates of SA minus SB by 1.5. So, we will get the 3-hour unit hydrograph in meter cube per second after dividing SA minus SB with 1.5. So, this is our required unit hydrograph, that is the 3-hour unit hydrograph. You look at the table carefully, here you can see certain ordinates are negative. While coming to last ordinate, for the time T is equal to 23 hour, we are having minus 0.7. This way some fluctuations can be observed while solving the problems related to S hydrograph, while deriving the unit hydrographs of different durations by making use of S hydrograph technique. So, there you need to make certain adjustment or smoothing of the curve so that it will reach 0 at the end time interval. So, instead of minus 0.7, we can assume it to be 0, and that is representing the 3-hour unit hydrograph. If you are plotting the curve, you can see here our 2-hour unit hydrograph is represented by this pink curve, and S hydrograph SA is given by this red curve, and SB is the lagged hydrograph which is represented by this green curve, and you can see both are having an equilibrium discharge after certain time. Those ordinates we haven't found out, we have stopped there because we were not interested in getting the S hydrograph ordinates. Our intention was to get the ordinates corresponding to 3-hour unit hydrograph, and from this we have found out the SA minus SB, that divided by T by D was giving us the 3-hour unit hydrograph, that is represented by this blue curve. So, whatever be the required duration, you can find out by making use of the S hydrograph technique. If the required duration is ND hours from GR unit hydrograph, if this n is integer or fraction, we can develop the NDR unit hydrograph by making use of the principle of S hydrograph. If n is an integer, easily we can do by making use of the principle of superposition. So, these are the different types of problems related to S hydrograph and unit hydrographs having different durations. So, here I am winding up this problem solving session. You can get so many exercise problems from these textbooks. Try to solve these for making the concepts very clear. Thank you.